for calculators, please notice that we're recording now, so the natterers, I love you, but stop. This is a question from, it's the example from our textbook. Oh, geez. Pause. It's the example from our textbook, and we just want to see how we can do this pretty quickly using our graphics calculator. And because we now know some of the basics about amplitude and period and all that sort of stuff, it's pretty good. So where are we going to go, people? Where are we going to go? Number 5. So hit number 5, graphing mode. I've got lots there, so we can delete pretty quickly. If you've borrowed a calculator from somebody else, you can see now it doesn't take long to just delete. Or you could unselect. Okay, and we are going to type in what we see. Okay, so we're going to go 3 sign, bracket, pop your fraction, pi. We're not worried about the fact that it's a t, because our calculator just deals with x. I did say grab a calculator, but that's all right. All over 6. Now you're going to be late. And we press enter, and then just wait for the rest of us once you've done that. Will, what should we check before I just press graph? We're going to check the min-max. We're also going to check that we're in radians, right? Very first thing. Why am I in radians? Because it's got pi in there. So as Will said, we want to go and check our scale. So how do I go and check my scale? What do? Shift, view window. So Shift F3, and we come up with this. Now the question is fantastic because they've actually given us our domain. Remember domain we talked about is our x values. What's our domain? What are they telling us is our domain? 0 to 24, it's in the question. So 0 I'm happy with. I'm going to go down here and set that. It's your decision. You can go 24. You could give yourself a little bit of a buffer. I'm going to go 24.5. Just so it's not right on the edge. Yeah. Some of you might want to go minus 0.5. So that's not right on the edge. Up to you. Okay. And then as Will said, we want to choose our suitable Y min and max. Now, are they okay? Are those min and maxes okay? We've got shaking of the head. Yep, adds. Why are they not okay? The amplitude, love the language, yep. The amplitude, which is that 3 in front of the sign, right? That 3, that's telling us that the graph is being pulled up to 3 and then down to -3. So we're going to go down. And we're going to just, you use your arrow keys to move down. And I'm going to change that to minus, do we want a buffer? Let's have a buffer. Minus 3.5 and then 3.5. Okay. And that should be pretty good to go. So I now press enter, and I can press enter again, and I get a beautiful sine graph. And this is, as we've read the question, it's representing the tide above the mean sea level on January. Now, obviously, some of these equations are going to get trickier, although not that bad. But when is the high tide and what is the maximum height? So how can I find the maximum? I mean, without even using a calculator, we know the maximum is the 3, yeah? How can I find the maximum on my calculator? Shift G solve, so Shift F5, and you can see there we've got a max. So if you press max, it comes up nicely. Don't worry if you can see on mine dy by dx, that's just a year 12 thing for derivative. So the maximum is the y value, 3, and it's occurring 3 minutes or hours. So this is now where you read the question, blah, 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 blah. T is the number of hours after midnight. So it's occurring 3 hours after midnight. Does that make sense to people? All right. So we've got the high tide and what is the maximum height? What is the height of the tide at 2 p.m.? So how many hours after midnight, so this is hours after midnight, how many hours after midnight is 2 p.m.? Who watches JAG? I watch JAG, 24-hour clock. Yep. So it's up till 12 o'clock, you got 12 hours, and then 2 o'clock is 2 more hours. So 14 hours. So I'm going to write on this. All right, T, oops, not T. That would mean X is 14. Now, if you accidentally got that wrong, you didn't know, and you just went 2, then you should write X equals 2. So then the marker knows what you're thinking. Don't just use technology and just put an answer down. Like, I love tech, but as a marker, it's really difficult when someone just puts a random number down. You go, how on earth did they do that? Okay, so X is 14. We're going to go back to our calculator, and I'm going to go, play with me now. Ready? We're going to go GSolve. Who remembers what we do? Anyone? Good. We want a Y calc. So this arrow here, F6, we're going to say more. And I want to do a Y calc. If I press F1, it's going to ask me, right? You want a Y calc, what's your X value? So by all means, you could actually sub it into your equation here, but hence we've got it on the calculator, let it do all the work. So we pop in 12, and oh, what is the high tide? It's at its original, the 0, if that's what it says there. I haven't read the question. The height of the, yeah, above sea level. It's the tide above the mean sea level, so it's right at the sea level. 14, I put in 12, sorry. Shift, viewing, trying to do a lot of things going at once. Y calc 14, thank you. So it is 2 point, I'm going 2 decimal places, 2.6 meters above sea level. Thanks for that. So just getting used to using your Y calc and X calc, and I'm assuming that some people out here who hadn't used their calculators before probably haven't used the X calc and Y calc, but you're getting used to it, and I'll come around and help you in a minute. So a ship can cross the harbour provided the tide is at least 2 meters above the mean sea level. When is crossing possible? Now you've got 2 options for this. I'm going to show you my preferred option. So I would actually go exit, and I would type in 2, because what you can see now is that red line above that, that is when it can cross. How do I find these points of intersection? Anybody? Anybody? Once again, our best friend, GSolve. That is going to be your go-to button. GSolve, I'm finding where 2 graphs intersect. What do you think I press? F5, intersection. Tells me that intersection there. I move with my arrow keys across, and I get them all. So it'll be between 1.39 and 4.6. So who can remember that? You have to remember that. 1.69. Yeah. I remember I've forgotten the first one. So we want to say it can be, don't write this, but it can be between was it 1.69? Huh? 39 and 4.6. So instead of us writing, and technically I should have written the time can be, we're going to write it like this. This is mathematics. We're going the time, it's in between 4.6 and 1.39, so we're saying it has to be greater than, so time is greater than 1.39, but less than 4.6. Okay, and what's the next one? Oh, thank you. 13, yeah, I should have just asked you to do it. 13.39 and 16.6. Okay, and you really want to suck up to the marker, put hours there. Okay, if you didn't want to do what I did and put in the y equals 2, okay, so I'm going to exit. I can go up here instead of deleting, I can just deselect. That comes up. I can do my GSolve more, and instead of Y calc, I can do X calc when Y is 2 meters and that works too. And you go there, then you can use your arrow key, get your next one, you get your next one. You get exactly the same answers. I just like my visual. So up to you what you want to use. Does that make sense? All right, so can't really see on mine, but we're going to go, the first thing I'm going to set my X min and max 0 to 12. So we're going to go Shift, View Window. So Shift F3, and that's going to be 0. I'm happy with that. And I'm going to go 12. You know, you can put 12.5 if you want, whatever. We good? Right, my minimum. Because the A value, the amplitude is 3,000, doesn't that mean it can be minus 3,000? But that 7,500, that's lifting the whole graph up. 7,000, so I'm going to say plus 7,500 there. Does that make sense? And then your maximum will be 3,000. What do you think? Plus 7,500. Okay, Aiden might want to look at that and go, oh, do you know what? I want a buffer. I'm going to round the 4,500 to 4,000. I'm going to put the 10,500 to 11,000. Your call. But if you left it at minus 3 and 3, you're not going to see anything. All right, press enter. All right, if it says invalid, you have typed something in that it doesn't like. Going on here, the population of grasshoppers after T weeks is estimated by. So if I'm doing A, and can you please listen carefully, because some of you might go, yeah, I know how to do this, but it is what you write down. So initially, how much time has passed initially? 0, right? So time is 0. So what I want you to write is P of 0. And then yes, I'm even going to ask you to actually rewrite this. And what you're doing is wherever T is, you are replacing it with 0. Now, 0 times pi is 0. 0 divided by 8 is 0. So we're doing sine of 0. Most of you should be able to do that in your head because we know sine of 0 is, is 0. Yeah. How do you know that? I do it because I'm going, that's where I know. I'm looking at the graph. Are you going graph or are you going unit circle?
Oh, I just said sine 0.
You just know it. You just know it. Okay. Show off, that's right. But we would confirm this is what we would do on our calculator, all right? Again, you can go GSolve, P of 0, you can either say that is your y-intercept or we're getting used to our y-calc here. So y-calc when x is 0, huzzah, 7,500, which is what we predicted. Agreed? Are we happy with that? No, grasshoppers. So when x is this, that's your notation. Taj, P of 0, that's saying what your T is. So maybe you might even want to put above that T equals 0, I don't know, but that's what it, grasshoppers. Grasshoppers. Okay, and then number 2, find the estimate after 5 weeks. So that's when we're saying T is 5 mathematically. Our third topic, we talk about maths notation, and it's like we're already using it now. P of 5 means go to your function and wherever the variable is, replace it with that 5. Okay, so again, you could go in and put that in your normal calculator, but because we've already got our graph happening here, we're going to go GSolve more ycalc when x is 5. Bingo, bango, bob. Goodness, can I read that? 10,000. Okay, now here is an ethical dilemma. If that was 10,271.4, should we round up? Because technically that's a grasshopper. Or are we going to round down? I'm going to be, I don't really mind. Do you know what? Like some people are going, technically a grasshopper. If this one is This is 10,271.6. You might go, hang on, 0.6. I don't actually see the grasshopper. So are we going to say that's 10,271 or 10,272? Oh, 10,000. I'll go with you. 10,272. Do you get my ethical question? Like you see a pregnant sheep, are you counting that as one sheep or two? Ethical dilemma. 1.5. What is the greatest population size over this interval? In other words, what are they asking you to do? G-solve. G-solve. Max, baby, max. Okay, there's not a lot that we can write for that. Okay, so we're going to press F5, max. So 10,500. All right, max. Now, can you just put yourself in a test situation? Boys, you put yourself in a test situation, you're rushing, and you accidentally, instead of putting 7,500, you put 750. Now, your answers are all going to be wrong. Do I see any working? No. Do I see what you have typed into your calculator? No. So what is my only recourse? Wrong. Bang. Lost easy marks. So please, 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 we love technology because it can make life easier. But if you accidentally type the wrong thing in, I've got nowhere to go. So always double check, see if your answer is reasonable. Okay? Really important. All right, next one. What is the population after, what is the population, when, read the question properly. When is the population 9,000? So for C, we're going P of what time? So P of T equals 9,000. If you wanted to, you can even say, I'm trying to find the time. It comes to our collator. And where do we go? It's our bestie, G-solve. But this time, what are we trying to find? B. C. We are trying to find our time, which is our x value. So it is now an xcalc. And look what happens. It asks you, what is your y value? What's our y value, Felipe? Felipe, what's our y value? Come on, here. This is it here. Right? 9,000. It's asking you, how long does it take for the maximum to be 9,000, okay? Are you with us? Good boy. So are you up with the G-calc? Okay. And did you get X-calc? And we just pop in 9,000. So we get 1.33. 1.33 weeks. We're going to do the same thing for part 2. Right? This time we're going, what's T when the population is 6,000? So we go to our calculator. Once again, we're going to go G-solve, more F6, but instead of Y-calc, we're going to do X-calc, and it comes up, what's your Y value? 6,000. Press enter. Oops. Good Lord. 9.33. Head. So we get 9.33. Should be typing this into your calculator. Come on. Just pause. So hello, sorry. Go back to part 1, see part 1. We've just had someone in the crowd say that we could, Abdul, could have 2 times when it is 9,000. Absolutely. So you just use your arrow keys. So it would be 1.33 weeks or 6.67 weeks. For those of you who want to sort of convert that to days and hours, by all means, but at the moment I'm just trying to get you to use your calculator. All right, and the last one, D. During what time intervals is the population, when is the population greater than? I hope you're looking at what I'm doing with the maths language, okay? I don't want to write the whole sentence down. P for population. This is my greater than symbol. P is greater than 10,000. If you want to write P is greater than 10,000 in words, knock yourself out. How am I going to do this? You can do your Xcalc again, but I'm going to go exit. I like to see it, 10,000. But you could have done exactly what you did for C part 1, okay? GSolve, intersection, I've got it's between, it's between 2.51 and 5.49 weeks. You don't want to do all of that hard work and leave off basic units and I go, oh, you would have had full marks, but oops. Would I be so mean? Yes. Can you just make sure that when you do questions like question 4, if I pull up the old textbook, they wrote this without the brackets, the second lot of brackets. And what happened when students were then typing it in, and it's even been in tests, they haven't written the second brackets, students would get just a straight line on their calculator. Because what your calculator will do if you don't have every single bracket there, it'll take the sine of pi on 7, which is just a number. It'll be like 3, and then it times it by the x value, and that's why you just get a straight out number. But they've taken on board and they've retyped the book. But sometimes in tests, you should still be aware that if you want to sign the whole thing, you've got to put brackets around it. Does that make sense? So everything else is pretty much what we're doing. It's just going and using your calculator, making sure you can get the right scale. Yeah? I'll come around, assist people. If you've got homework questions from the end of exercise 7E3, I'll assist you with that. If you've got questions with this, that's good too. And then if you go to your OneNote, we talked about this a little bit yesterday, but revision. Please, can you read my tips? And not just my tips, but got them from elsewhere, about how you can prepare and what you need to do to prepare for a test. Boys, please read. There's your checkbox about what should or what can be in your test. Make sure that you go through and suss. We've got review set questions there. That's an awful lot of questions. You might not be able to do every single one. As an example, review set 5A, question 1, it's about changing degrees to radians, radians to degrees. Now it's got part A, B, C, D. You might just go, oh, I'll do part A, or I'll do part D. So be selective in the questions that you choose to do. Make the sense? In previous tests, you've got, how many have you got there? 1, 2, there's a video of 21 and 22. Girls, do you mind? Please read this. We talked about it yesterday. Do not do those tests and think, oh, I can do each one of those tests. I'm good to go. Yours aren't going to be exactly the same as these ones, okay? So practice, make your 1 page of notes before you even try those tests and try and do them under test conditions. That's Ange out. If we just look at the second question, right, notice they don't give you the domain. So how are we going to know how long it takes to complete 1 revolution? What do we call that? The time that it takes to complete 1 revolution. The period. So remember that stuff that we were talking about before? We've got period equals, what's the formula? period equals 2 pi over b. So if we look at question 2, what is our b value? So what is the value in front of our x or our t? Looking at question 2, what's the coefficient of t? 2 pi on 3. Yeah, it's not a trick question, it's what you see. So for question 2, b is 2 pi on 3. So we're going to whack that in here. We're going to go period is 2 pi divided by b, which is 2 pi over 3. You can use your calculator to work this out. I can't be stuffed going back to it, so I know fractions. Get rid of a divide by. What do? Replace a divide with a times. Flip your fraction. So our period is actually 3. If we read the question again, how long does it take to, it's going to complete 3 minutes to complete one revolution of the Ferris wheel. Does that seem reasonable? Okay, so when we're doing this now in our calculator, you will go 0 to 3 for your x domain. Make it the sense? Awesome.